Hello everyone, in this video I will show you how automatic error mapping works in these Express errors using Prisma as an example. We will work our way from a manual example to integrating the libraries so we can clearly see the difference. In this simple example we have our own middlewares for handling errors. We also have several roads. The first middleware handles recognized Prisma errors, the second one handles all remaining application errors. The project also includes a custom asynchronous route wrapper. It catches rejected promises and passes them to the next Express middleware. This file contains the manual Prisma error mapping. As this is a manual process, we need to define and handle everything ourselves. We also maintain a separate message for each error code. The mapper must also recognize different Prisma error classes. Known request errors, initialization errors, and validation errors have different properties, so the project handles them separately. Finally, the mapper constructs the response object with the status, code, and message. This file contains roads that intentionally trigger genuine Prisma errors. In this video, I will demonstrate errors P2000, P2002, P2003, P2025, and P1001. Each road performs a genuine Prisma operation. The errors are not created manually or simulated. First, I will run the project using the original manual error mapper. Before testing, I will reset the demo data to a known state. The first example is Prisma P2002. This error occurs when the operation violates a unique constraint. The next error is P2025. The road tries to update the user that does not exist. P2003 is a foreign key constraint error. The road tries to create a post with the author ID does not exist. P2000 means that the provided value is too long for database column. P2001 is a Prisma installation error that means that database server cannot be reached. All these responses work correctly, however the project currently needs its own async wrapper, Prisma class detection, status mapping, message mapping, response builder, and two middlewares error. I will replace this infrastructure with these Express errors. I will install these Express errors from npm. The library provides the async handler, a global Express error handler, and the built-in mappers for popular validation, authentication, and database library. I no longer need the local async routes function and two custom middlewares. Instead, I import a setConfig, async handler, and error handler from these Express errors. I also import Prisma because I want to provide the real Prisma error classes to the library. The configuration is intentionally small. In error classes, I provide Prisma so the mapper can perform strict instance of checks against the real Prisma error classes. In needMappers, I enable only the Prisma mappers because the demo does not use the other supported libraries. If needMappers is not provided, all available mappers are enabled by default. Next, I replace the local async route wrapper with async handler. Its purpose is similar. It catches asynchronous errors and forward them to the Express. Finally, I replace both custom middlewares with one error handler. It must be registered after all application routes. At this point, async routes.js and Prisma errors.js are not longer required for error handling, so we can remove them. The roads still produce a real Prisma P2002 error. The library detects the Prisma error and mapped it to conflict automatically. The built-in logger also gives us useful diagnostic information. We can see the request method and URL, the mapped message, the result status code, the stack trace, and whether the error is operational. This is useful because the client received a consistent HTTP response while the developer still had enough context to investigate the original error. With a format error, I can define the final JSON structure returned by the API that have our application. And now format response is changed as we defined in our application. For now, P2025 is automatically mapped into not found error. This Express error library correctly identified the other errors and mapped them correctly. The logs also contain additional information. But what about situation where the application is already in production? Is sensitive information being leaked from the library? Of course not. The library can tell whether it is a development environment or in production. This message is useful for developer, but it should be more understated for users. Sensitive information has been replaced with an vague response. What do you think about this approach? Do you prefer automatic library mapping, or do you prefer maintaining all error mapping directly inside your project? You can share your opinion in the comments. The full documentation and source code are available on the official website and GitHub. I will leave both links inside the description. This is the first video I plan series about JS Express errors. In next video I will cover more featured and integration example. Thank you for your watching.